Hello and welcome to another of our FME educational webinars. This time our focus is on how FME can be utilised in the architecture, engineering and construction, or sometimes referred to as the AEC sector. My name's David Eagle and I'm the FME Division Manager at One Spatial. I'm also joined in today's session by my colleague Charlie Doherty, who's available in the session and will be monitoring the chat function. So if you have any questions you'd like to send our way, as usual we'll do our best to deal with anything you might ask during the session. But if we can't deal with it quickly, we'll follow up with you straight after the session if you leave us some contact details. And just to prove that we are real human beings here, I'm just going to turn my camera on so you can see we're here live, and there you go. Proof that we're actually in the office together as well. During this period, not much time in the office, but we've had a few meetings in the office recently, which is nice to get back to a little bit of normality. So welcome everybody and thank you for joining us. So here's the agenda for today, after a brief introduction to who One Spatial are. Just in case this is your first time with us, we'll get straight into the focus for the session, which is what we see commonly as the core data challenges in the AEC sector. That of siloed data, poor data accessibility and connectivity, and lots of manual and often repetitive tasks. Using a typical project life cycle, we're going to attempt to highlight some of the ways you might consider using FME to alleviate at least a little of the pain that you'll increasingly realise you don't have to suffer. Now, as I said, if it's your first time with us, welcome. We're One Spatial and our focus as a business is to help you unlock the value of your data. We're keen to live in a smarter world, and we think that making your data smarter and of a greater quality is just one way in which we can help ourselves to do that. We're a software development company in our own right, and we've been building software for 50 years to help manage our customers' data quality. But we recognise that there are other companies in our space that offer huge value in what they do that can complement our expertise. Over the years, we've selected a number of firms to work closely with, and the partnership that I intend to focus on today is our Platinum partnership with Safe Software. They make the FME platform, and Safe are based in Vancouver in Canada. And we're a reseller partner in the UK and Australia, with experts also in Ireland, France, Belgium, and the United States. As a business, we focus our attention on 3 core vertical markets with dedicated solutions in each. But we find that because FME enables data connectivity to all sorts of locations, databases and APIs, that almost any sector that finds it necessary to move or manipulate their data can get value from FME. The logos you see here are just some of the companies leveraging the power of FME to assist them. So, what are the data challenges in the architecture, engineering and construction sector? Well, we've boiled them down into 3 main areas of data: location, accessibility and automation. First up, there's definitely a problem of data silos in disparate systems across project teams. Projects are definitely not getting any less complex, especially the large infrastructure projects that often incorporate different political boundaries, let alone different companies and partners in a joint venture. These complex projects have assorted internal and external stakeholders and use a multitude of different systems and applications. Data can end up stuck in silos, making it hard for stakeholders to access data and use it when, where and how they need it. Data is also not easily accessible to stakeholders who need it. An example might be that a definitive copy of a MicroStation DGN file containing the new highway layout might be versioned and shared in, say, Bentley ProjectWise, or an equivalent AutoCAD DWG is available in Autodesk A360. But because the highways team don't have access, they're issued a copy of the file. whilst the ecology team are emailed a spreadsheet of survey data instead of being given read-only access to the database that stores the survey data. This challenge is so common, and it's generally the one that gets project teams into the biggest bind. Data is duplicated, and it's hard to understand if you're accessing the most up-to-date information or data from a much earlier project stage that isn't giving you the full picture to make your decision against. And finally, lack of automation in project workflows. Repetitive tasks are completed manually, or sometimes worse still, only partially. Manual tasks mean that skilled personnel aren't necessarily used effectively, and partial completion of tasks means that data errors or incompatibility can creep into the workflow. To overcome these challenges, you need a data integration solution, and that might mean that considering FME is worthy of a little of your time. Let's take a look at how a project we worked on recently served to tackle all three of these challenges to a differing degree. Working with a major retail construction and property management firm, we discovered that during the build phase of a new shopping site, the firm formed individual service level agreements with their architectural partners, against which their drawing quality would be assessed. It was these drawing files, and in particular the building information models, or BIM, that would control the progress of the construction and determine what got built, using what components. Up until our involvement, the firm did a manual QA and QC of approximately 50 building information models a week in order to keep the construction on track. But they had no way of auditing the quality of what they were receiving. Plus, they could only manually check about 10% of the data. To address the challenge of siloed data, we helped by building an FME process that linked all the necessary raw data materials together, with FME directly connecting to material lookup lists and the spreadsheets that contained the allowed building specifications. Then an automated routine was constructed that was built in such a way that it could be used to quality check 100% of the 50 IFC files each week against the client's exacting requirements. And to solve the challenge of information accessibility, the summary report that the process produced was surfaced in a business intelligence tool called Tableau. FME prepared the data that was ingested into a dashboard, and ultimately it presented not only the metrics by which the construction firm could monitor their SLA, but it also produced an error report that showed where and what problems or omissions existed with the data that they'd submitted. Using FME, we automatically consumed the BIM IFC files, allowing us to expose the hierarchy of building information stored in the files. The customer stored the key parts of their BIM schema in an external Excel resource file, as this allowed them to easily amend it to support the project. The contractor's file was then automatically assessed against the allowable rules, and an enhanced summary was produced that could be connected into a pre-configured Tableau dashboard. The dashboard was the final piece in the jigsaw puzzle, because it addressed the challenge of data accessibility by allowing the data owners and project stakeholders to understand the quality of the information against which they were making construction decisions. And it also allowed the architectural contractors to improve their level of service with targeted changes to address identified issues. In order to achieve BIM compliance, FME checked that the supplied files adhered to the stringent rules set by the construction company. They could then automatically check how closely the contractors were adhering to their schema and the rules specific to the complex that was under construction. For example, only certain component types were allowed to be used, so ramps and escalators were allowed, but the building did not include any elevators, so they were an invalid component type. All drawings had to be versioned with the correct phase of work or the correct work package to ensure that there was synchronization between the data being reviewed. Also, as different parts of the construction site had different numbers of floors, the number of allowable levels was an important attribute check on the data. You'd be surprised at how many times rooms were found to be attributed with a level number that was too great for the overall containing building. And finally, there were all sorts of IDs in use on the project, from part numbers to material codes, and they all needed to have and approved syntax and the correct length. The focus of the project was just one of the AEC data challenges that of moving the process from a fully manual process to automating it. At the end, it was possible to check a full set of BIM files in the same time that it took to check over 10% of one of the files manually. Almost as a byproduct of the project, though, the other areas of FME's capabilities came into play, namely the ability to natively connect to data without having to duplicate it or translate it first. And at the other end of the process, we were able to simplify the reporting phase by pushing the results into a structure that it could easily be consumed by a tool like Tableau that was dedicated to presenting the data as information against which a decision could be made by those that need to make it. So, who are Safe Software? Well, they've been around for a number of years. 1993 was when they were born, and they're still owned by the two guys that founded the company back then, Don and Dale. The FME platform is an international product used by thousands of companies across the world, and the user community is extremely collaborative. I think you'll struggle to find a more friendly bunch of technical data users keen to help with your next data challenge. Lastly, the most important point to make is that FME future-proofs your projects with its enormous catalogue of data format support. So if you care about data with or without geometry, FME can more than likely help you connect to it, transform it, and automate your process. And at One Spatial then, our FME division is wholly focused on helping our customers to get the best value they can from their investment in FME. We do that first by ensuring that FME is actually the best fit for you through product evaluation and the provision of demonstrations dedicated to your challenge. We also provide consultancy to help you build your automations, and if you prefer to do it yourself, we have a schedule of training classes that we can deliver online or, all being well, at some point face-to-face. We also sell FME, and we can offer you a number of different pricing structures and currencies to suit you. All of our software agreements also include maintenance and technical support to suit your needs. Back to the topic in hand then, and FME helps AEC companies increase operational efficiency throughout the project lifecycle by integrating data across data containers, systems, and software platforms. And whether they're installed locally or in the cloud, we can deal with both. This integration can streamline project workflows and make data accessible to the stakeholders that need it, where, when, and how it's required, and it'll improve engagement between partners and the end client. In the rest of the session, we're going to focus in and walk through 3 stages of the AEC project lifecycle, starting with the initial planning and design phase, the build and inspection phase, and culminating in operational activities, which can focus on traditional facilities management, or FM. We'll see how data integration and specifically FME can help maximize the value of your data and increase operational efficiency at each stage of the life cycle. At the plan and design stage then, different groups of people are involved in the project workflow and the decision-making process. These groups include interior designers, urban planners, engineers, surveyors, and a range of other specialist professionals like ecologists and drone surveyors, each often with their own set of tools and software. With FME, you can integrate assets and data from disparate sources, including BIM, CAD, GIS, point clouds, field survey, and lots more. Some of the typical workflows we see in this area are transferring CAD to GIS, combining BIM and GIS, and transfer of LiDAR data to 3D models. But putting FME at the heart of your data management strategy can ultimately help you to form and subsequently manage your central data store. There are 3 areas that you can make an impact on fairly quickly. You can transform, validate, and integrate data from different systems, teams, and applications with automated workflows, all the time whilst retaining data quality. At One Spatial, we have 50 years experience working with our customers' data quality challenges, and as a result, we have a number of solutions that include ad hoc validation, bespoke apps or front ends, through to complete rules catalog management using tools like our own One Integrate. Streamlining project management with automated workflows is also hugely important, because with these routines we can help to keep important project information up to date, such as automated processes that go out to external services and APIs on a schedule to harvest data required by project teams, like environmental designation data from the likes of Natural England, to land ownership data from the Land Registry. These admin tasks take time and effort, so if they can be automated out of the weekly task list, they return efficiencies to the project in the form of operatives being able to spend more time on data analysis instead of data preparation. The impact of data connectivity and process automation is that you improve stakeholder engagement and cross-team collaboration too. And with a central data store for easier data sharing and informed decision making, you can make that collaboration faster and more reliable. We're so frequently now hearing about the formation of a CDE, or Common Data Environment. Only last week we met a client in the rail industry for the first time who's looking for a solution to help them form a CDE, gathering data from disparate sources, collating it, checking it and loading it into a definitive single source from where it can be served to who needs it, and importantly where it can be versioned and archived. These CDE aren't new though. Certainly in our industry it's just a new way of referring to an old suggested approach to best practice, building a single source of the truth, or single point of truth, sometimes shortened to SPOT as an acronym. If you go this route though, you can reduce duplication, increase access and improve reliability and ownership of one of your most important assets, your data. These CDE are very commonly document management systems or databases that, depending on the focus, may or may not contain spatial data. Since FME has support for DMS like SharePoint, ProjectWise and Autodesk A360, along with insert, update and delete capabilities on database standards like Oracle, SQL Server, Postgres and the cloud equivalent standards, along with many more, it's often the solution with the best access to all of the required data repositories that an AEC organization may have across the business. To help put some of what I'm covering into context, I'd urge you to go and take a look at a couple of the sessions delivered by engineering firms at our recent FME World Fair event in May. Both sessions can be found if you go to our on-demand webpage at onespatial.com/on-demand. The first session from Gwilym O'Donovan at Mott MacDonald was all about automating the management and availability of project documents with FME to ensure project collaboration was using the correct, most up-to-date content. To catch Gwilym's session, you just need to fast forward to 51 minutes in, and then you'll see his session in detail. Then once you've found that session, immediately afterwards, so straight after Gwilym's slot, about an hour and 5 minutes into the session, up will pop Jenny Wilburn from Atkins. She focuses her session on bringing disparate data sources to life to help visualize risk of vegetation encroachment on the UK rail network. For this project, Jenny explains how FME helped them manage the processing of a huge volume of LiDAR data. So I think it's time to have a go at a demo to introduce you to FME Desktop, and in this example the focus is on performing a CAD to GIS translation, but it's also a transformation because the geometry needs to be significantly manipulated to get it into a fit state to be used in the GIS. Once built then, this process can be used repeatedly to restructure all of the data for the area in question. So I'm just going to pop up FME Workbench onto the screen and hopefully you can see that. What we've got here is a partially built workspace. I'm slightly cheating because it's a demo, but you can see that I've got the application here is called FME Workbench, and I've got a partially authored workspace. A workspace is a script that you write using the visual programming tool of FME. You can see here in the little navigator window over on the left hand side that I have an input. This is a CAD file, and you see if we go and inspect it, there's a little visual preview window that allows us to look at the detail. And what we've got here is a CAD data set of, in this case, line work that represents plots or buildings. You can see there's also an annotation layer, which if I use the control key on my keyboard, I can sort of add that as part of the selection. And what's the case in a lot of CAD data sets is that CAD engineers annotate their data, and you can see that's the situation here. We've got a text object right in the middle of this feature that is an ID that references that plot of land. So we want to do a couple of things, because we're going to translate this into a GIS format. This is going to end up as an Esri file geodatabase over on the right hand side here. But we're going to use a transformer called the Area Builder, and that will effectively take all the polylines and join them together to create polygons. And each of these polygons can be attributed with information using our annotation layer. So we've got something here that we could form an area from now, rather than having just the line work. And if we go and look at the transformer up the top here, transformers, by the way, are little utilities that allow us to carry out a particular function on the data set. In this case, we're using a transformer called the text property extractor, which goes to the geometry object, the label itself, and it takes the value and it will embed it as an attribute of the data into an attribute, in this case called text string. There's the label content that we've got access to. Now, I need to relate these features to one another, so I'm going to go and use the quick add function in Workbench to go and add in a new transformer. And I want the point on area overlayer transformer here. I'm going to take my text object, and I'm going to take my now area object, and I'm going to relate the two together by checking effectively, is the point inside the polygon, and if it is, take any attributes that are stored on the point and join them to the polygon so that it gives it an ID. That's the plan. So if I run this process, it'll read the data from the previous stage, and you can now see that if we go and look at the polygon features that we've got access to in here, you can see that I've now got a text string attached to the actual geometry. And then the last step really is to go and use a transformer called the database joiner. And the database joiner allows us to go off to an external database. In our case, I've got a little SQLite file, SQLite database, which, because again this is a demo, I have a little way of pre-configuring this interface. And normally you would define the format you were reading, consuming from, tell it where the database is, define the join key to the table that matters. And what I'm going to do is go to this parcel table that's in the SQLite dataset, and I'm going to bring back a whole bunch of additional fields to enrich my polygons. Then for any joins that are successful, I'm going to write them out to a schema that I've got defined in a feature class in an Esri geodatabase. So if I run this process, that will go out using the primary key that is the ID that I fetched from my label. Joined onto the polygon, I can then query the database where the IDs match and bring back some additional information back to my resulting features. And you can see here that now I've got things like a flag, a lot number, a LU code, a block ID, all the extra details that are wanted in order to populate my target schema. And then I can go and have a look at the output, and you can see here, if I drag in, I now have a geodatabase called buildings.gdb, and I can also go and view the output data, so the geodatabase itself. So there's our results visible in the structure that we've produced. So that's just a very quick example to show you the detail. And I've just got a comment in from somebody there. This process, of course, relies on the annotation being inside the features, which is not always the case. I completely agree. And actually, one of the things that we often see with CAD files is things like labels operating as leader. They're attached to features with leader lines, or they have proximity to the polygon geometry that you want to associate it to. So that can be a little bit of a challenge. There are tools like neighbor finder transformers to find the nearest neighbor, and then you can cycle through the nearest labels, and you can use regular expressions to work out which one is of a particular length, to decide which one you want to associate with your feature. So there are ways and means, but this obviously is a perfect scenario of all the labels exactly sitting inside. Although there is a data problem, you can see actually in this process there is a couple of unjoined features. These are two polygons that do not have a label inside them. So I've also got another question. So is there a way to navigate to individual feature classes within the database from FME? So I might not answer exactly what you're asking there. I think what you're saying is, can you load data into a specific feature class in a geodatabase, or can you consume a specific feature class from a geodatabase? You certainly can. I mean, there is there are a number of different format readers that you can go and select. So you can see that if you want to go and get data out of a specific feature class, you can choose a geodatabase reader just on the geodatabase format itself. There is a free and open source reader and writer in FME, but there is also an official one. This requires you to have some Esri software installed on your machine, but if you do, then you can use the slightly richer and more feature-rich way of reading and writing geodatabases. So reading and writing geodatabases is possible. You can also insert, update, and delete into particular feature classes. You can do queries against those data sets. So databases generally allow you to do SQL queries or a where clause to bring back specific information from a particular class in a data set. So there's a few different options there, but really the point of that is just to show you a little bit of the construction of a script in FME Desktop. But whilst that capability is the bread and butter for FME, going through the steps we've just covered in FME Workbench is not ideal for a broad audience of users, because not all users will be able to learn how to use FME or needs to. So in these scenarios where we have a process that we need to make available as a service to a broader group of users, we're going to want to appify it, for want of a better phrase. So here's an example where we've uploaded our workspace to FME Server and created something called a workspace app. It's a way of hiding the complexity of our workspace behind a simple, configurable user interface that allows us the ability to have unauthenticated or authenticated access. Plus, since you build it through a simple form-based interface, you also don't have to be a web developer to build it. So I'm just going to run a sort of a little demo here. Here you can see we've got an interface onto which we simply drag our AutoCAD DWG file, and it goes away and triggers the workspace to run behind the scenes. And it's exactly the same workspace that we were just running. It performs the database join to enrich the features. It also builds the attributes and property parcels and converts the AutoCAD file to an Esri geodatabase that we can quickly go and inspect. And this is a clip, zip and ship example. Effectively, you're uploading a file, you get back a zip file with the data in the produced structure and format. So here we have an automation process built and turned into an app to make it more accessible to a wide range of staff, or maybe even contractors. So here's the little results that we can go and inspect in the data inspector, and you can see that result straight out there. The visual preview window that we were looking at a moment ago in Workbench, the data inspector is a more sort of feature-rich, dedicated application, and now we can see that we've got the same result in that output file. So next we're going to move on to the construction phase, and so while not quite as hungry to adopt digital as some of the other stages of the AEC project lifecycle, construction companies are starting to incorporate technologies into operations that reduce costs and increase safety. And reality capture and 3D surveying make it possible to perform surveys and inspections virtually, reducing the need to go on site, and importantly, during a pandemic, reducing the need to physically interact with colleagues unnecessarily, or certainly less frequently than having to do repeat site visits. During the construction phase, drones can also be used to provide an overview of the site to monitor progress and overall safety. The same construction firm that I mentioned earlier scheduled weekly flights from an independent contractor who supplied them with a full ortho photo of the site each week, along with LiDAR data. Both data sets were pre-processed by FME to make them ready to be consumed by their visualization software solution. And as a construction company sort of continues, drone data can be used to create 3D models to verify what's been built at each stage, and it can then be checked against the design model. With FME, you can transform large point cloud data sets into raster data sets, into 2D features, and also precision 3D models. With numerous ways to manipulate and process your data, you can easily customize your data analysis workflow to make the most out of your point clouds and help you make fact-based decisions. Digital technologies are also driving the adoption of connected construction. So drones, wearables, sensors and GPS tracking services are revolutionizing job sites and capturing valuable information. For example, you could leverage FME to connect and integrate data from IoT sources to manage labor and material more efficiently on construction sites, and construction managers can assess the status of material delivery and installation, the location of workers, and how they're using machinery in real time. Since so many devices are connected these days, FME can gain access to asset inventories via an API or process timecard data and perform analysis on booked effort before logging resource requests in, say, a contractor's database. So now, just to put a little of that into context, I'm going to demonstrate transforming LiDAR and CAD data into a 3D model and exporting it to a PDF for easy sharing. Here you can see I have a CAD dataset, and you can see that I've got, in this example, building extents stored as polygons in 2D. I have X and Y vertices that make up those polygons. I've also got a LiDAR dataset. This is a LAS file for a city. And you can see that it's a small portion of the city with a gap in the middle. There's a river running through the middle, and you can see that we've got 3D entities that store classified information for sort of height values. And it's, to be honest, it's, in this example, it's the height that I care about. We're using a clipper transformer to effectively cookie cut the LiDAR data with the building extents. And then there is a point cloud statistics calculator that is going to allow us to grab the average height of each of these buildings and assign it to the building, the 2D extents of the building. You can see here that we've got only the LiDAR data that overlaps the individual buildings themselves. This is then our next step, where we're using the 3D Forcer, which forces our average height onto the Z axis of the feature, and then the extruder allows us to turn that Z value into an extruded cylinder or polygon that gives us a representation of the building, so that we can start to see the impact of, say, shadowing from tall buildings, or we can see the relationship between adjacent buildings in this scenario. But I guess the important part of this is that we're then writing the results to a geospatial PDF, a 3D PDF. And this is an interesting format for data sharing, because most people have got Adobe Reader installed on their machines, and most people know how to sort of loosely navigate their way around a PDF. You can see there are options to sort of turn layers on and off. We've got two layers that we've written into here, a buildings layer and a ground layer. We switch the ground layer off to allow us to easily interrogate each building, and you can see that FME gives us the ability to write the attribution into here as well, so we can see that by inspecting individual buildings we can get back the height values for those buildings directly in Adobe PDF format. So it's an interesting format for data sharing. I sometimes refer to it as GIS Lite in the context of this, because you can give a complex data set to somebody without without much tuition. You can get them up to speed fairly quickly with how to interrogate the results. Now let's move on to look at how data integration can help increase efficiencies in facilities and asset management after construction is completed. And digital twins has been a buzzword in the AEC industry in recent years, and it's becoming a trend in smart asset management as a digital replica of the real world physical asset. Digital twins are made possible by integrating the as-built drawing from various systems along with IoT sensors that gather data from the real physical world for further integration and analysis. When creating a digital twin of a building, FME can help you integrate different asset data, from basic spatial information to added intelligence from disparate sources like 3D models, floor plans, material information, and internal asset management systems that you use, as well as external systems like those owned and managed by contractors and partner organizations, other parts of the supply chain, or other members of your joint venture. You can also make use of FME to help you ensure that the data stored in the digital twin is always up to date. Centralized asset information allows easy use of data and ensures the data is always available to all relevant stakeholders, so they can make real-time informed decisions. And when talking about real-time decision making, the Internet of Things can really help, especially given how connected our buildings are starting to become. Now, many of you on our call today will be starting to get smart meters and smart heating systems with the ability to control the temperature of your own home from an app without the need to physically spin the dial on your thermostat anymore. And the same is true for our offices and factories. This FME workspace on screen is an example of a work order generation process. What does that mean? Well, in a scenario where a building in your care all of a sudden registers a temperature of 40 degrees, that may mean that Brian in accounts has been fiddling with the aircon again, or more likely one of the aircon units in that building has failed. Now, this workspace reads a packet of JSON, effectively a structured text file that's made up of key value pairs. In the JSON snippet here at the top of the screen, you can see that we have a temperature tag followed by a temperature value. This file contains all the details we need about our anomalous event that we care about. It's issued by a sensor that's monitoring the temperature in key parts of the building that matter to us. And in our case, when the temperature exceeds a specific threshold, the event is triggered. FME parses the message, works out from the sensor ID provided which building and which part of that building has the anomaly, and posts the details to the CityWorks application, within which a work order is generated to get a maintenance visit booked to go and inspect and resolve the problem. And here's that work order. posted to CityWorks. You can see that the task description has been posted to inspect the aircon hardware, and the description highlights what the trigger for the event has been and timestamps it. But there's a missing part here. What I haven't explained is how FME was triggered in the first place. The workspace on the previous slide is just the script effectively that does the hard work. It receives, processes and posts the message. But the temperature event sensed by the sensor is what that process consumes. But the event and the action have to be tied together somehow, and that's down to the magic of something called a webhook, orchestrated by FME server actively listening for that event to happen. Now, I could go into the details of webhooks here, but since I'm starting to run out of time, I'm going to tell you that a webhook is a URL that can send messages in real time to other applications, and then I'm going to leave it there because in favor of actually directing you to another one of our FME World Fair events that was run by my colleague Simon Green. Simon did a complete 101 training session on webhooks earlier in May and showed how they can help you send messages to, say, Microsoft Teams automatically, and FME also can trigger updates in a spreadsheet when a change is made in, say, ArcGIS Online. And if any of that sounds interesting, I'd urge you to go and take a look at his session recording. It's over on our FME World Fair event day that we did on the 12th of May, and it's at onespatial.com/on-demand, so that's onespatial.com/on-demand. And just shoot forward on that 12th of May recording to 30 minutes in, and then you'll see his session. So he did about a 20-minute session on webhooks and went into lots of detail about those. So do go and follow up on that one. So as you can see, data integration plays a significant role in helping you to achieve operational efficiencies throughout the full project lifecycle. By implementing a data integration solution such as the FME platform, you can make sure data is connected across systems, teams and applications. FME's automated features help you to streamline your project workflows from documentation to communication and to inform information updates. By making data easily accessible to everyone, your team can plan, design, build and operate more efficiently and, importantly, more collaboratively. So now you've seen a little of what you can do with FME in the context of the AEC sector, you might be interested in finding out a little bit more about the costs associated with an FME solution, or perhaps where and how you can deploy it to help you. If you are, then by all means get in touch with us at fme@onespatial.com and we can tell you about the types of subscription that are available or how you can cost effectively buy just 1 or 2 licenses. FME also has a number of platforms onto which you can deploy it, and there is scope for some short-term pay-as-you-go style options with some of the enterprise solutions. Or maybe you'd like to do a little bit of your own research first, or perhaps you're already a user and you just want to learn some new skills. Well, to find out what training we offer, what other FME webinars are coming up, or if you just want to dig into some of the hours of material that we have recorded and hosted on our on-demand pages on onespatial.com, just follow some of these short URLs to get a little bit more detail, or reach out to us at fme@onespatial.com for some help or for a quotation. Alternatively, a URL you mustn't forget is community.safe.com, because that's where all the tutorials and how-to articles are located, including the chat forum where you can ask thousands of FME users what their experience is with a specific challenge you might have. If you're already a customer of ours though, or on an active maintenance and support agreement, you can access our priority support service via support@onespatial.com. Though, if you're not sure what the status of your existing FME license estate is, just drop Charlie a note either now in the chat or after the session, and she'll let you know what you're entitled to. And that's it for today. So I'd like to thank you all very much for joining us live, and we hope you'll join us again in the next FME session on the 26th of August. Just go to onespatial.com/events to find out what the topic is, and you can register over there. So thank you very much. We'll hang on for a few minutes just to pick up any further questions, but other than that, thank you all very much, and we hope to see you again soon.